Okay, so just to recall, whatever this is from your school level mathematics, just plot the graph. If you plot the graph of xy equals to 1, then you will get these curves, right? Red curves. If you plot x equals to 0, then you will get this violet color. Or if you plot y equals to 0, then you will get the green curve. The straight line here, straight line is also curved, whose curvature is infinity. So we'll study the curvature also. Now the question is, will the curves intersect with each other? The answer will be no. Here x equals to 0 is this line, this vertical line, and y equals to 0, this is the horizontal line. And this curve is xy equals to 1. And if you take xy equals to 2, then you will get a curve more like this one, this type of curve. It will go far from the origin. Let us take only this curve. Similar conclusion can be drawn for other curves also. Now here, as you can see from this graph, for x equals to 10, this line, x equals to 15, this line. So after 15, maybe we can see that at x equals to 20, they are actually meeting at each other. They are intersecting at each other. But if you zoom it, try to make a zoom it, or let us try. Then you will get that they are not actually meeting at each other. They are not crossing their paths. Whatever you take, no matter how much you go far, okay, if you zoom it, then you can see that they are not actually meeting at each other. Yeah, here it is. Think about the point at 100. You can see it at 100 point, at x equals to 100, they are not actually meeting. There is always a gap between them, between these curves. Same conclusion can be drawn for the vertical line also. Okay. That y-axis and this red curve will not actually intersect each other. But if you just change just a slight, if you make just a slight change, instead of 0, if you make here -1 or -2, 0. Or 0.5, or here also 0.25 also, maybe -0.25, everything, whatever you take, the line will go, okay, then the line will be go up and down. And in this case, you will get lines of this form. Okay, so that is why you can see that this line is moving when the values of x and y are changing. Okay. Except this x equals to 0 and y equals to 0, all other curves will intersect this curve. You can see here. Okay. So if you check the value of x and y are changing, here you can see. Okay. When we are changing the value of x, we are dragging this pointer, and then we can see that this violet color, it is actually changing. It is intersecting with the red curve. So here you can see that there is a intersection between these two curves. If we change the value of x, so x equals to 0.3 will give you this scenario that they will intersect at some point. Same case you can see here also, that if you change the y equals to 2.4, then or if you change the value of y, then you will get that it will intersect. So with this graphical notation, we proceed to define. There may be some other cases also. If we have a function like this is f of xy. These curves are actually here. F of xy. Okay. These curves are f of xy. And here, if you see that this dotted line, here it is, y equals to 1, and this one is y equals to minus 1. Again, you can take, this is x equals to 1, and this one is x equals to minus 1. So if you have this situation, then you can see, even if you zoom it, at this figure, you can see that they are intersecting each other, they are meeting, but it is not. If you zoom it here also, they will never intersect with each other. So with this graphical knowledge, we will try to define a new concept, which we call as asymptote. So asymptote to a curve. So given a curve, for example, a curve is given, a variable point p x y. The point is varying its position. It is a variable point, so you can go there in this way. Okay, if it's moving, and the curve is actually given as g of xy, comma 0. You can write it. For example, x square plus y square, or some, like we have seen, xy equals to 1, or you can write xy minus 1 equals to 0. Okay. So this is the form of g of xy. Okay. Now it says, if the distance of the point px, y, p of xy from a straight line, for example, you can draw one straight line, or you can take here straight line in this way, or you may be taking another straight line. Okay. So it is saying that if we have such situation, and if we allow x and y, or both tends to infinity, okay, x tends to infinity, y tends to infinity, okay, then the line is called an asymptote of the curve. That means if this is the line minus p comma x, the distance between, actually the distance between the line and the point px is tending to 0 as x or y tends to infinity. This line can be here also, horizontal or vertical. X or y or both tends to infinity. Now, if you look at the distance between this point here, for example, y equals to 1, here y equals to 2, for example, y equals to 4, then y equals to 5. And if you move forward, okay, if you go in this way, that is y tending to infinity, then this red curve and this blue curve will come to, they come very close to each other. But remember, like previously we have seen here, they will never intersect. No matter, if you zoom it, then you will see that there is a gap between them. So distance is never zero. But in mathematical sense, we will say they will meet. The distance between two curves will be zero if they meet at infinity. So at infinity, they will meet. That means in mathematical sense, they will meet at infinity. But if you plot the graph, you will see that there is always a gap because we cannot reach to the infinity. We can never be. So if we have a horizontal line, then it is called horizontal asymptote. If this vertical line is an asymptote, then we call it a vertical asymptote. There is another possibility which we'll discuss as the inclined or oblique asymptote. For example, if the curve is of this form and we have an inclined line. So from here, what we have, this is this lines is y equals to some constant. Okay, y equals to some b, and this is x equals to some a. But this line will be y equals to ax plus b type inclined line. So that means the slope will be, okay, it will make some angle to the x-axis and y-axis. Okay, so that is inclined oblique asymptote. Now we'll discuss each of the asymptotes properly. So the idea of asymptote, do you first understand that it is a line if it satisfies this relation that the distance between the line and the point of the curve, actually, P is a variable point on the given curve. Okay, so if we have this situation that the distance is getting slowly to 0. So here also the distance is getting slowly tending to 0. So these lines will be called as asymptotes. This is also asymptote to this curve. Okay. Now, like I have shown in the very beginning, that if you zoom it at the point 100, x equals to 100, there also you can see that there is a gap between the curves. So asymptote will never intersect the curves. Okay. So if we define a vertical asymptote, so how do we define it? For example, the given curve is g of xy equals to 0. Then we want to solve for y because we want to get the vertical asymptote. So if we have, so y will be written in terms of px by q of x. Okay. Now fx will be at the point fx because this is our y will be written as a f of x. Okay. So this will be going to infinity at point x equals to a. Okay. Either it is going to positive infinity or negative infinity. That will be discussed. So only case when we have the denominator q of x equals to 0 at x equals to a. So this is the meaning of this sentence. Then q of a equals to 0. That means a is a root of q of x equals to 0. Okay. So this is for your information. Now, slowly we will go to the topic how to find vertical and how to find any kind of asymptote, not only vertical. We have other type of asymptotes also. So we'll look at soon. They're coming soon. We'll discuss them very soon. Now, for example, if we take y equals to this curve, x minus 1 whole cube, 1 upon x minus 1 whole cube. Now, if you take x goes to 0 from the positive direction, okay, then this fx is going to plus infinity. And if you take fx negative from the left hand side, then it is going to negative infinity. So for both the cases, if you remember that if it is going to either positive infinity or negative infinity or both of the cases, then we call it a asymptote, that x equals to a is an asymptote. In fact, in this case, it will be vertical because x equals to a gives a vertical asymptote. So this is from the definition. Okay. Later we'll see how to, technical way how to get a systematic method to find asymptotes. So this is from definition. We get that the curves approaches from the opposite ends at x equals to 1. Okay. So at x equals to 1 here, they will approach to each other, but they will never intersect with each other. What we can see, because we are having odd number, so that is why it will go opposite direction. Now if we have square term instead of 2, if we have a square term, then we will have, they will reach in the same direction. Okay. So x equals to, if you go with the positive direction from the right hand side limit and the left hand side limit, So both cases, fx will converge to positive infinity. So that means the curve will actually tend to infinity in the same direction along the particle asymptote. So why these asymptotes are important? Okay, to study the characteristic of a curve. Because if, for suppose, the explicit form is not given, okay, only say that x equals to 1 is a asymptote. Okay, asymptote, and to the asymptote of a curve, and the curve, and they satisfy these limits. Okay, then the task is to plot the curve plus this is given, these limits are given. Okay, then you have to plot the curve. This is simple examples. Maybe for engineering problem you may get difficult problems, but this is more or less the application of asymptote. They will be helpful to find out the curve. Now you can see that x equals to 1 is a vertical asymptote, but at the same time you can see that if you take this horizontal line, which is this horizontal line is actually, what is it? Y equals to 0. So this is also one asymptote to the curve. So this asymptote will be called as horizontal asymptote. How do we define mathematically? So this is geometrically we can see here. So horizontal asymptote, similar process we'll do. We'll write down the given function in terms of x. Ax will be written as in terms of function of y. Okay, and now here also this b will be a root of q. So the denominator we have to make it q of y will be 0 at y equals to b. That means y equals to b is a root of q of y equals to 0. So these ideas are actually from Jane Anger book. These ideas are from this Jane Anger. That is why I have kept the equation numbers. Okay. But the concept is, if you think about the same graph that we have discussed, y equals to 1 by x minus 1 whole cube. So this can be written as of this form. You can rewrite it. Okay. And again, if you rewrite this function as a, then the target is to make the function go to infinity. Okay, and this can be done as y equals to, so from this 0 direction, the right hand limit, because y is in the denominator. Okay, so if you take the right hand limit about 0, then it is going to plus infinity. If you take the negative, that is the left hand limit, then it is going to negative infinity. Okay, so here we can say that by definition that y equals to 0 is a horizontal asymptote of the given curve. Now if you plot this diagram, okay, so you look like this. The same diagram, earlier we had seen that this is our vertical, x equals to 1 is our vertical or a vertical asymptote, but at the same time y equals to 0 is our horizontal asymptote to the same curve. The curve is y equals to 1 upon x minus 1 cube. This also is written as x equals to, just now we have seen x equals to y 1 by 3 plus 1 by, okay, here it is. So x is written in terms of y, and otherwise y is written in terms of x. Okay. So this is, here it is fx, here we call it h of y. So both will go to infinity as x goes to 1. Similarly, this will go to infinity as y go to 0. So that is why this particular line will be called vertical asymptote, and this one is horizontal asymptote. Okay. Now, if you remember the other example, when we had the curve is actually tending to infinity from the both sides about x equals to 1, when we had y equals to 1 by x minus 1 whole square. So for this curve, we have seen x1 is a vertical asymptote. Similarly, if you write it in terms of y, okay, then you will get that for both cases, for the left hand side limit and the right hand side limit. In fact, we note that if we define, in this case, we have to be careful. Okay, from the left hand side limit, y tends to, okay, the left hand side limit, if you go from here, so that is not actually defined. Okay. There is another alternative way to define the horizontal asymptote. Okay, and that is we have to write the limit. If limit, okay, plus minus x goes to infinity, f of x equals to b, then this y equals to b is an horizontal asymptote. So for this particular example, if you take it here, Here the f of x is this one, y equals to f of x, 1 upon x minus 1 whole square. So what we are writing, x plus minus go to infinity. If you allow, or if you take x plus minus go to infinity over this function limit, okay, so plus minus infinity, if you take it, then if this is 0, in fact this will be 0, 1 by infinity is 0. If you try to find the, then this will imply y equals to 0 is an asymptote, horizontal asymptote of the curve. So this is another way to find out. Either you write x in terms of h of y, or you can calculate the same, you can use the same function, but in that case you have to take the limit from x tends to, you can go to minus infinity and plus infinity. So both the direction plus infinity and then minus infinity. You take these values. So if it is satisfied, then you can claim that this is one horizontal asymptote of the curve. Now there is another, the concept that is called inclined or oblique asymptote. Remember, inclined line means it will make some angle y equals to ax plus b, where b is non-zero. Okay. In fact, it can, if it is b equals to 0 also, then it will pass through the origin. It can pass through origin also, no problem. But the thing is, it will be inclined. Neither horizontal line nor a vertical line. It will be an inclined line. So these derivations are not a part of our syllabus. Okay, this is for your information. I have included. The thing is, in order to calculate the inclined asymptote, we need to find out these values. This is 1. Okay. Then this is 2. This is 3. And this is 4. So if we find these 4 limits, okay, if you find these 4 limits, then you can get the inclined asymptote. Okay, so we will look at one example, that how do we actually find out asymptotes. Okay. There is another alternative way, so we will discuss it later, maybe in the next class, the alternative method. Okay. So here, so let us try to find out the asymptotes. Here it is mentioned asymptotes. So that means check for all cases. First one is horizontal. Second one is vertical. Third one is inclined. So we go for first one, that is horizontal. Or you can go for vertical also, there is no problem. So what we have to do? First we have to write y equals to f of x. So we'll go for vertical one. Okay. So x minus 1 whole square by 2x plus 3. So here, what we get? X square plus, or you can just write x minus 1 whole square divided by, let us take half outside, then x plus, not half, 3 by 2. Now, if you allow x goes to 3 by 2 from the right hand side, then what you will get? Y equals to fx will go to plus infinity. And if you take,
Shouldn't it be
So minus 3.
3 by 2, sir?
Sir, minus.
yes, right. Thank you. Okay. Not because we have to make it 0, right? This should be 0 only if minus 3 by 2 the right hand side. So x goes to minus 3 by 2, then left hand side limit. Then we get y fx goes to minus infinity. So together we can say that x equals to minus 3 by 2 is a particle asymptote of the given curve. So if you try to plot the diagram, just take the help of, so y equals to x minus 1 whole square divided by 2x plus 3. Equals to minus 3 by 2. So let me just show you the graph, how it will look like. Then we'll come back again. So here it is. This is our given function, and x equals to minus 3 by 2. So if you zoom it, you can see that apparently it looks like it is actually matching at 1.5 minus 1.5 point. But if you zoom it and if you take it outside, no matter how long you go, here also, there also you can see the difference. So it is minus negative 67. Then again, if you go in the positive direction also, if you go here also 50, or maybe you can go to 100 also. Okay. There also you can see that these are not matching. So this is the asymptote of the given curve here. Okay. Now we come back and discuss the other topics. So here, let us stop it, and I will share again the original screen. Okay, how about horizontal? Horizontal. So we'll try to find out. Can you tell me what is horizontal? If you can calculate fast.
Y equals to
Do
0.
it quickly. Y equals to 0. You think that is correct? So for horizontal, let us write down the function again. Y equals to x minus 1 whole square by 2x plus 3. Let us write x square plus minus 2x plus 1 divided by 2x plus 3. So if you take it, divide by x square minus 2x plus 1 divide by x. Similarly, you divide by x here also. Then you get x minus 2 plus 1 by x divided by 2 plus 3 by x. Okay. Now, if you define in this form, actually, other way. So, if you remember that we have to take the limit x plus minus going to infinity, the same function y equals to fx. So here we will write this function x minus 2 by 1 by x divided by 2 plus 3 by x. Okay. What is it? This is going to be infinity, right? Or plus minus infinity. It is not a finite number. Because this will go to 0 and this will go to 0, but x is here. So if you allow x plus infinity, then it becomes plus infinity. If you allow negative infinity, then it will become negative infinity. So the value is not finite. So now if you go back and check, we have discussed that there is another formula for here. So if this b is a finite, in fact, I forgot to mention that the distance between the origin and the asymptote will be finite. Okay. So let me write down this remark. Asymptotes, the distance between origin and an asymptote of a curve is finite. In fact, here we have mentioned that B is a finite number. There exists a number. Infinity does not exist. Okay. So that is why, in fact, in other words, in mathematical sense, we call it there exists a number. Infinity is not a number. It does not exist. This is just a concept that if we go further and further, what will happen? So this is not a point or any number. So B, this should be finite. Actually, here I should have mentioned that this should be less than, strictly less than infinity. So this is a finite number. So if it is finite, then we call it a horizontal asymptote. But now we are seeing that this is not the finite limit is not existing. So there is no horizontal asymptote. Of the curve. In fact, if you go and let me show again the curve actually, y equals to x minus 1 whole square divided by 2x plus 3. Then what we have seen, x equals to minus 3 by 2. So that is one vertical asymptote. But if you look at y equals to 0 or y equals to anything, it is actually meeting. Okay, or y equals to minus 1. Okay. So let me share this screen again. So I think it is visible to you. Yeah, here it is. If you look at this blue line, this line is minus 3 by 2. So this is our vertical asymptote. But if you look at y equals to 0, okay, you see y equals to 0, if we put this 1 comma 0, it is the point of intersection. But if it is a horizontal asymptote, then it will never intersect. They will not have any common point. Here it is 1 comma 0. And in fact, if you moved any horizontal line, other horizontal lines, so you can see that they are actually intersecting. If you move with these horizontal lines, this is going to intersect. Let us see. From 0, if you take 0, then 1, 2, 3, 4, and up to 10, then it is going to intersect. Okay, let us forget about the 0 point. Let us forget about this vertical point also, vertical line also. Now take only this y. Here you can see. Okay, if you take these points, Okay. You may think that this y equals to -1 or -2 is not going to intersect. But if you zoom, so maybe it look like that they are actually intersecting. At some point they will intersect. But apparently it is not intersecting yet. So y negative. But if you increase the negative value, that means -7, so then they are actually intersecting. What happens if you take y equals to -1 or -3/2? Is it intersecting? But it is not going to. So, in fact, there is another concept that we are forgetting. So, can you tell me what is that?
Inclined asymptote.
Yeah, the distance between the two curves will go to 0. Take the distances. This is the one curve and this is our asymptote. The distance is actually getting increased one by day by point by point. It is increasing. Okay. But we are supposed to get, if we go infinity, x equals to minus infinity, then this is supposed to get 0, tending to 0, but it is getting increasing. Similarly, for here also, in this direction also, if you go to plus infinity, then the distance between this curve and the another curve, this is the asymptote, not asymptote. If you call it asymptote, then everything gone. So the thing is, this, for example, y equals to some minus a point. Okay. So this distance is not getting to 0. Distance between the line, this is the line and this is the curve. Okay. And the curve should go to 0. It should not go to increase. So that is why there is no horizontal asymptote for this case. Now we try to find out the inclined. So wait for another maximum 10 minutes. So I'll complete this today. So for that, what we have to do, we need to find out 4 limits. Number A, we have to find out those 4 limits. Limit A equals to x go to plus infinity divided fx by a, fx by x. Okay. Then if you try to find out limit x go to infinity, what is fx? Our function is y equals to fx, which is given as x minus 1 whole square divided by 2x plus 3. Okay. So you write down x square plus, not plus, this is minus 2x plus 1. Okay. Divided by 2x plus 3. Okay. Now, if you, so this is our x, this is our fx. Since x is already there, so we need to multiply 1 by x. Okay. So this, the denominator will become now 2x square plus 3x. But we want to find out the limit. So that is why let us divide by x square. Okay. So this will become limit x go to infinity, x goes to infinity, then this will become 1 plus, not plus, this is minus 2 by x plus 1 by x square divided by 2 by 2x square by x square, so this is 2, and 3 by x. Now if you allow x tends to infinity, so this limit is going to be 1 by 2, because this is going to be 0, this is also going to be 0, this is also going to be 0. Okay, so that is why a equals to, we have got 2. Now remember that inclined y equals to ax plus b, that is our inclined asymptote. The form of the asymptote will be inclined of this form. Okay, so now if you go back to the next quantity that we have to calculate is a, so yeah, that is b equals to limit x goes to infinity fx minus half time of x. Okay, this is a working formula. You may ask that how I am getting this thing. So these derivations are not a part of our syllabus, as I mentioned.
So if there is infinity, then how can I get b? So it should be 0 now.
B, no, we have to calculate the limit. Not b is not infinity. We have to calculate the limit. Here, look at this. Here, b will be found depending on the value of a, because a we have found already is the slope of the straight line. Okay, so these 4 equations are important, these 4 limits, in fact. Okay, if you think about the negative, then you have to take the absolute value, and then try to find out the value. And for if you try to find out the negative also, then you take these values. Okay. Are we clear? Okay. So a we have found equals to half. Now we want to find, that is why we have put here. Okay, the formula is actually this one. Okay. So in place of a, we will substitute 2, half. And now we get here limit x goes to infinity, fx is x square minus 2x plus 1 divided by what is it, 2x plus 3, then minus half of x. If you just do this simplification, then you will get limit x goes to infinity minus 7x plus 2 divided by 2 times, this is 2x plus 3. So again, you will get the limit as minus 7 by 2. Hence, the inclined asymptote, you can write is given by y equals to ax plus b. So here we have a equals to half x plus minus 7 by 2. So this is nothing but half x minus 7/2. Now, if you go back and plot, yeah, this diagram, what is it? Y equals to half of x minus 7/2. So what you get? Oh, okay, right. There is a mistake. Half of x, not 2yx. Yeah, this. This should not supposed to be 7/2. No, what is?
So 7/4.
No. Yeah, let me just correct. 7/4. Yeah. Yes. So this is 7/4. You see, if you do any mistake, then the graph will help you to correct. So this would be 4. Yeah, this is 4. Okay, sorry for the mistake. So here you substitute 4. Now you can see this black straight line. Okay, the distance between this, either you go in the positive direction or you go in the negative direction. Okay, if you try to save it, let us not understand. Yeah, export it. Not. Okay. Here also, this is actually our y equals to half x minus 7/4. So if you go as x tends to infinity, allow, and x tends to minus infinity, or let us not write in this way. So minus infinity. Okay, x tends to minus infinity. Then the distance is actually getting less and less. It is tending to 0. So here also, if you go in this direction, then also the distance between the line and the curve are actually decreasing. You have seen that if you do not calculate the limits properly, just now you have seen that if you write here 7/2, then this is going to actually intersect. A asymptote cannot intersect. That means we may have done any mistake in the calculating the limits. Okay, so if you take the help of this graphing plot also, this is a very helpful tool. Okay, Siva, tell me. You have raised your hand. Any doubt? So this is all for today. Yeah, we will discuss more about the other aspects of this asymptotes in the next class.
So can you tell a book which has derivations of this slant asymptotes?
Can you repeat? I did not get your question.
Tell a book which contains these derivations of this slant asymptotes.
Yeah, okay, these derivations I have included now. If you, I have already mentioned that this topic I will be discussing from Jane Iyengar book. Here it is. Okay, but
sir.
the soft copy is not available, so I have taken some snaps. So I have included this here. all the book content is actually here. If you follow this PDF and try to solve the problems that I give. Okay, these are two exercises I have given, I have included. Yeah, those derivations are actually here. Okay, so for inclined, in fact, this is not part of our syllabus, but I still include it. We just have to calculate these limits. These limits, okay. This 4 limits is sufficient to calculate the inclined asymptote. But if you want to see the proofs also, I have included here. Okay, so you can go through it. I hope you will understand.
Okay, sir.
We will discuss the alternative method. What is the alternative method? But this method is not always applicable, because this method demands the function should be written as a polynomial of this form. Okay, but not every function can be written as a polynomial. But we can definitely find the limits in terms of this. So there is this method is sometimes applicable for some problems, but not always. For example, this one, this method is actually applicable. Okay. So yeah, so these are verify these results. These are your exercises or your practice. So try to complete this by Monday, these two examples. And Monday we will discuss something more about the asymptotes. In fact, we have discussed more all the cases of asymptote. Anyway, we'll revise it again and then try to conclude. So if there are no doubt, you may leave the meet.